Hello, and welcome to the final lecture in the Introduction to Python course. Today, we'll be learning about the Pandas library. It is a very powerful package for manipulating tables. You can import the data by reading your Excel files, CSV files, or any other format you can think of. It is built on top of NumPy, so writing lower level code is not necessary to extract, manipulate, or clean the data. Joining, merging, filtering, reshaping, or pivoting the datasets is quite simple and straightforward. So in Pandas, there are two main data structures, a series and a data frame. So a series is just a one-dimensional array with indexes, which is our row indicator. And a data frame is like a table with columns. You can think of a data frame as like an Excel sheet. And it can contain columns with different data types like strings and integers, unlike NumPy. So here's an example on how to create a Pandas series and a Pandas data frame. So first of all, we import the Panda package and refer to it as PD. Now to create a Panda series, we call the pd.series function and give it a list. To create a Pandas data frame, you can just call the pd.dataframe function and give it your input data along with the name of your columns. In this case, A, B, C, D. So here's another example on how to create a Pandas data frame using a dictionary. So the keys in the dictionary will represent the column names and the value will represent the row values of the table. And you can save the table as a CSV using the to_CSV function. So let's learn more about the Pandas library by actually reading a dataset called Senseless Income Dataset, which was downloaded from the UCI machine learning repository. So we are going to cover the functions info, head, tail, column values, and dtype in the next few slides. So firstly, we created a list called columns that contain the appropriate column names for our data, since our original CSV file didn't contain the column names. To read the CSV file in Pandas, you use the read_CSV function. It takes the path to the file as a parameter, while the name represents the column names, and we assign it to our created list. Now to have an initial look at the data, you can use the .head function. By default, it will show you the first 5 rows of the data. If you'd like to specify the number of rows to be displayed in the head function, you can do so by specifying it in the parentheses. For example, if I want to display the first 10 rows of my data, I can write df.head parenthesis 10, and it will show the first 10 rows of my data. So the info function displays the columns, the type, the rows, and the memory used by the data frame. So as you can see, we had in total 32,561 entries. So the column age is of the type integer, work class is a string, education is a string, and so on. You can also see the number of non-null elements, which means the number of elements that were not missing in the data. And you can see the whole data set has no missing values. And the total memory usage is around 3.7 megabytes. So the tail function works exactly like the head function, but instead of displaying the first 5 elements of the data frame, it displays the last 5 elements of the data frame by default. And just like the head function, you can specify the number of rows to be displayed by writing them in the parentheses. So here we have the sample function of Pandas, and it just displays a random sample of rows taken from the data frame. The number inside the parenthesis represents the number of rows to be taken from our dataset. So the dtypes represent the type of the data stored in each column. For example, the age is stored as integers, work class is stored as a string, and so on. And to print the name of your columns, you can type df, which is your data frame, dot columns, and it will print out all the column names of our data frame. So let's say you wanted to rename one of your column names. To do that, you can call the rename function of Pandas, and inside the parenthesis, columns equals curly braces, your previous name of the column and your new name of the column. Now here in place equals to true is important. Now if in place equals to true, the original data frame gets updated, which means that the new column name will be country in our data frame. However, if in place is false, or if you do not specify in place equals true, it returns a copy of the data frame and our original data frame does not get updated. So here's a small list of descriptive functions in Python that help you understand your data a little bit better. For example, the describe function summarizes the statistics of each numerical column. The value count method returns the number of occurrences of each unique value for that particular column. The mean function returns the mean of the column, while the unique returns the unique values for that particular column. So here's how you use the describe function. And as you can see, it shows you the count, the mean, the standard deviation, the minimum, maximum, the 25th, median, and the 75th percentile of each of your numerical columns. So let's say I wanted to find the unique values and the number of occurrences of those values inside a particular column of my data frame. To do that, first of all, I call the column, in this case, education, inside the square brackets, and I call the function dot value counts, and it displays me the unique values and the number of occurrences of those values inside our dataset. For example, 1,723 samples belong to masters, while 5,355 samples belong to bachelors in terms of education. So here's just an example on how to calculate the mean or print the unique elements of a particular column. To do that, you need to access the column, for example, hours per week or education, dot the function that you want to use, mean or unique. So let's see how can you access elements of your Pandas data frame. To do that, Pandas provides two functions, loc and iloc. So loc selects a row and column by its name, and it takes a label as an input, while the iloc selects a row or column by the index position, and it takes an integer as an input. So here's an example on how to access a particular row of your data frame using the iloc function. So to do that, you call the data frame df.iloc function, and inside the square brackets, write the name of the row that you want to print. In this case, it's the fourth row. So here's another example on how to access multiple rows from your data frame using the iloc function. In this case, we are trying to access the first three rows of our data frame. Here's another example on how to access multiple rows, let's say from the row 10 all the way to 14. So here's an example on how to use the loc function. So here we are trying to access the first three rows and the column age and education. So let's say I wanted to filter my data frame based on a particular column, in this case age, and I want only the rows that contain the age greater than 50. So similar to NumPy arrays, you can create a Boolean array to filter your data frame. To do that, write the df, which is your data frame, and the column that you want to filter on, in this case age, and give me the rows where the age is greater than 50. I'm looking at only the first 10 values of my filtered Boolean array. So now that we know how to create a Boolean array, you can use the Boolean array to filter your whole data frame. In this case, we are displaying all the data frame where the age is greater than 50, and we are only looking at the first 5 values of that particular data frame. So here we are creating another Boolean array, but this time we are creating a Boolean array using two different conditions. So the age should be greater than or equal to 50, and the gender should be male. So here, just like before, we are filtering on the whole data and displaying only the rows where the age is greater than 50 and the gender is male. So here is an example of a data frame where you have a missing value, and in Pandas, missing values are represented by nans. So if you have some missing values in your data frame which are represented by nans in Pandas, you can fill those missing values using the fill_na function of Pandas. In our case, null_df had a missing value in its fourth row, and here we are replacing it with 1000. Typically, you would replace those missing values with either zeros or the mean or the mod or the median of the column. So far, we have seen how to deal with missing values by replacing them with a number that makes sense to us. It could be 0, mean, mod, or median. However, Pandas also allows us to drop any missing values from our data frame. So if you want to drop any particular row that contains any missing value, you can use the drop_na function. And how equals to any parameter tells us that if there is any missing value in any particular column, then just drop that particular row. Let's say I wanted to split my data based on a particular column and apply some function on those split data. I can use the group by function in Pandas to do so. So in our case, let's say I wanted to split my data based on relationship, and I wanted to count the number of rows corresponding to each unique value in the column relationship. So I call the group by function and in parentheses give it the name of the column that I want to split my data by and then call the function count. And as you can see, for example, 13,193 rows correspond to the relationship husband, 981 correspond to other relatives, and so on. Here is another example where I wanted to split my data based on the column education and I wanted to calculate the mean of the split data. To do so, I again call the group by function, give it the column education that I want to split the data by, and then calculate the mean of those split data. So for example, people who did their education until 10th grade have a mean age of 37.4, and the people who did their education until 11th grade had a mean age of 32.35. So let's say I wanted to sort my data frame based on a particular column. To do so, I can use the sort underscore values function in Pandas. So let's say in our case, we wanted to sort our data frame by age. So I call the sort underscore values function and I give the parameter by the column age and I look at the first 10 rows of that particular data frame. And you can see the age starts from lowest and it goes to the highest. Here is just another piece of code where I want to filter my data frame where hours per week is greater than 20 and I'm looking at the first 5 elements of my filtered data frame. Now here we are trying to sort our data frame but not based on any value but based on the indexes. To do that, I can call the sort underscore index function and I want it to sort based on the descending order. And here I'm only looking at the first 5 elements of the resulting data frame. So the last function that we are going to be covering today in Pandas is the merge function, which is used to combine multiple data frames. In the code below, we have two data frames, left underscore df, which contains two columns, names and salary, and right underscore df, which contains the same columns but different values for the salary. To merge these two data frames, we call the merge function, which takes two data frames as input, and the column on which we want to combine on, in our case, names. The resulting data frame contains two columns now, salary underscore x, which represents values from the first data frame, and salary underscore y, which represents values from the second data frame. And with that, we come to an end to our introduction to Python course. Now that we have learned the basics of pandas, you should definitely go and try to use these functions on your own data. If you have any questions, please feel free to contact me or Matt or any other person in Launchpad, and we'll be very happy to help you out.